Cross-laminated timber. The wood that's replacing concrete. What you're looking at isn't a concrete high-rise. It's a mass timber building made almost entirely of wood. CLT is one of the fastest-growing building materials in the world and one of our best tools for cutting construction's massive carbon footprint. Today, we're breaking down how CLT is made, how it's used, how engineers build it, and why it's reshaping modern construction. What is CLT? CLT is an engineered wood panel made by gluing layers of lumber boards together, each layer rotated 90 degrees from the one below it. This cross-grain pattern gives CLT strength in both directions, allowing it to behave like a structural slab, similar to precast concrete. How CLT is manufactured. Lumber selection. Boards are kiln-dried to 12% moisture to prevent shrinkage and warping later. Machine stress rating, MSR. Modern CLT plants use laser and X-ray scanners to assign each board a structural grade. This ensures predictable stiffness, critical for tall timber buildings. Finger jointing. Boards are cut with interlocking fingers and glued to create long, defect-free laminations. Adhesive application. Polyurethane adhesives dominate because they cure without heat and have excellent creep resistance. Pressing. Hydraulic presses apply uniform pressure across the entire panel, sometimes up to 2.5 MPa. Some factories use vacuum presses for more consistent bonding. CNC machining. Openings for windows, doors, MEP penetrations, and connection pockets are cut with millimeter precision. CLT panels arrive prefabricated and ready to install, making construction feel more like assembling giant Lego bricks. Structural uses. Floors and roofs, spanning 6 to 9 meters without beams. Load-bearing and non-load-bearing walls. Shear cores for elevators and stairs, replacing concrete cores in many mid-rise buildings. Modular volumetric units, entire rooms built off-site. Speed advantage. Frames that take months in concrete can be erected in weeks with CLT. Global examples. Mjosternet, Norway, 18 stories. Ascent, Milwaukee, 25 stories, world's tallest timber tower. Hoho, Vienna, hybrid timber tower. Brock Commons, Canada, 18-story student residence. CLT panels can be connected using steel angle brackets. Steel angle brackets are used for shear transfer between wall and floor panels. They are often paired with hold-downs for uplift resistance. Half-lap and step joints. Half-lap and step joints provide continuity in walls and roofs. These joints reduce stress concentrations and improve diaphragm action. Spline connections. Spline connections are used for floor panels to create a continuous diaphragm. Spline stiffness affects seismic performance. Self-tapping screws. Modern self-tapping screws can be 400 to 600 millimeters long. Angled screw patterns at 45 degrees improve withdrawal resistance and moment capacity. Concealed connectors. Concealed connectors are used in architecturally exposed timber. Hidden plates maintain clean aesthetics. Environmental and performance benefits. Carbon storage. 1 cubic meter of CLT stores roughly 800 to 900 kilograms of CO2. A mid-rise building can store thousands of tons. Embodied carbon reduction. Switching from concrete to CLT can reduce embodied carbon by 20 to 50% depending on the project. Fire performance. Thick timber chars at 0.6 to 0.7 millimeters per min. Engineers design panels with sacrificial layers to meet 1 or 2 hour fire ratings. Seismic performance. CLT's low mass reduces seismic forces. Connections can be designed to yield and dissipate energy. Despite the mentioned advantages, there are some limitations and challenges when using CLT panels. Moisture. CLT must be protected during construction. Wetting can cause panel swelling, adhesive line weakening, fungal growth. Acoustic performance. CLT alone has poor airborne sound insulation. Floors often require concrete topping, resilient layers, acoustic mats, vibration. Long-span CLT floors can feel bouncy. Engineers apply the following measures. Thicker panels, composite topping, tune mass dampers. Supply chain. CLT is regionally produced. Transporting large panels can be costly. CLT won't replace concrete and steel everywhere, but it's proving that wood, engineered smartly, can build higher, faster, and cleaner than most people ever expected. Next time you walk into a building with warm, visible wood ceilings and walls, look closer. It might not just be a design choice. It might be the structure itself, quietly storing carbon above your head.